In the first episode, we have evaluated integrals involving algebraic functions. In this second episode, we are going to use the substitution method to evaluate integrals involving trigonometric functions or product of trigonometric functions. Let's recall the formula. We have integral of f of g of x, g prime of x dx is equal to f of u du using the substitution u equals to g of x. For our first example, we have integral of cosine 5x plus 3 dx. So in this case, we just let u to be our angle 5x plus 3. So that means derivative of u now will be derivative of 5x plus 3 is 5 dx. But we do not need the 5, so we just divide by 5 both sides. So this will be dx equals to du over 5. So using this substitution, we can rewrite our integral as cosine u, where dx now is replaced by du over 5. So we will get 1/5 times the integral of cosine u du. And recall that the integral of cosine is just sine. So this will be 1/5 sine u plus c. But we can replace the u here. So this will be 1/5 sine of 5x plus 3 plus c. For letter B, we have integral of x times secant squared of x squared plus 1 dx. As before, we can let u to be our angle. So u is x squared plus 1. Taking the derivatives both sides, this will give us du equals to 2x dx. Now, from our integral, we have x multiplied by dx. So we only need x multiplied by dx. So we divide by 2 both sides. We will get du over 2 equals to x dx. Now, rewriting this integral, we will have integral of secant squared. Well, x squared plus 1, we let that to be u, times x dx now will be equal to du over 2. So, moving the 1/2 outside of the integral, we will have integral of secant squared u du. And we know that the integral of secant squared is just tangent. So this will be 1/2 tangent u plus c. Now replacing now the u, we will get 1/2 tangent of x squared plus 1 plus c. Let's consider our second example. For letter A, we have integral of sine squared x cosine x dx. We can actually rewrite this as integral of sine x squared, because sine squared x is sine x times sine x, cosine x dx. For this case, we have to choose the u properly. If we choose u to be sine x, the derivative of sine x is cosine x, which is what we need. So let u be equal to sine x. Derivative of u is du. Derivative of sine x is cosine x dx, which is actually what we need, cosine x dx here. So this will be equal to integral sine x now will be replaced by u. The power is 2 times cosine x dx is actually du. So we have now a very simple integral, which is an integral of power function u squared. The power is 2. So integrating this will be u cubed over 3 plus c. After replacing the u, this will give us sine x raised to 3 over 3 plus c. Or we can rewrite this as sine cube x over 3 plus c. For letter B, we have the integral of the square root of sine of pi x times cosine of pi x dx. We can actually rewrite this as sine pi x raised to 1/2 times cosine pi x. This is almost similar to the first case. So we will let u to be sine pi x. taking the derivative on the left side, we will get du. On the right, the derivative of sine is actually cosine, so we have pi x, but we have to apply the chain rule. We have to multiply by the derivative of the angle. So the derivative of pi x is just pi, and then we have dx. Take note, we do not need the pi here, so we can divide pi both sides. So this will be cosine pi x dx, which is actually what we need. So replacing now this information, we'll get integral of sine pi x is just u raised to 1/2 times cosine pi x dx is actually du over pi. Now we can move 1 over pi outside of the integral, and we have integral now of u raised to 1/2 du. So this is now a simple integral. We can actually use the power rule. So 1 over pi times. Now to get this integral, we just have to add 1 to the power 1/2, but 1/2 plus 1 is 3/2. So this would be u raised to 3/2 divided by 3 over 2, but the 2 will go up, plus a c. Rewriting this one, this would be 2 over 3 pi. Well, the u is actually sine pi x, and everything is raised to 3/2 plus the constant c. Finally, we are asked to find the integral of 2 plus tangent 5x raised to 3 multiplied by secant squared 5x dx. Note that tangent and secant squared are related. In particular, if we take the derivative of tangent, it will be secant squared. So we can let u here to be 2 plus tangent 5x, the entire base. So this will be derivative on the left side, du. Derivative of 2 is 0. Derivative of tangent will give us secant squared 5x. But we still have to apply the chain rule, multiply by the derivative of the angle, which is 5x. So derivative of 5x is 5. And we have to write dx. But we do not need 5 here, so we just divide 5 both sides. So this will be secant squared 5x dx, which is actually what we need. So rewriting now our integral, we will get integral of this entire expression is just u raised to 3 times secant squared 5x dx is actually du over 5. We can move 1/5 outside of the integral of u cubed du and apply power rule. We will get now 1/5. We'll just add 1 to the power, so this would be u raised to 4 divided by 4 plus a c. Replacing now the u, we will get 1 over 20. So our u is 2 plus tangent 5x. So 2 plus tangent 5x. Everything is raised to power 4 plus the constant c.